Assalamualaikum everyone. How are you guys? स्ट्रीम अब शुरू हो गई. अच्छा भाई ये कौन है? अयान. वालेकुम अस्सलाम व रहमतुल्लाहि व बरकातुहू. Sir, can you please give me the best way to get my examination? I started at maths my YouTube. First student to give the examination? What do you mean? First student to give the examination. Yes, you can use the book by Sue Pemberton. That's perfectly all right. And what else? I'm giving 7 examinations, total of 10. Okay, Ayan, so what I can understand so far is math is your strong subject and you're contemplating giving advanced maths as well. Is that correct? To go further and to give an advanced examination. So the thing is, my opinion or anybody else's opinion doesn't matter or shouldn't matter to you. What matters is how well prepared you are. So, do a few past paper questions, see where you stand. And Vasito, you don't have a lot of time. I mean, today is the last day to register if you're a private student, at least in Pakistan. But see where you stand and then decide for yourself. Concepts, I'm afraid we don't have time for concepts. Either we can do concepts or we can do past paper questions. Reason why I don't want to do concepts is because I already have a video or multiple videos where I have covered the concepts. Okay? Walaikum Assalam. Can you make a kind of it? I did a stream recently only where I did circle theorems. Yes, angle properties of circles. Anyway, let's start. Let's not waste any more time. Will area under the curve come into P1? It can, but if it comes in P1, that means the question is such that you can do it without a calculator. Sir, PNC में एक type का question आता है जहाँ पे you have to seat some people and there will be some restrictions like those 2 people. Yeah, I've done those questions. Check out my permutation combination stream. I've done those questions. Do we have relative velocity? No. Relative velocity was removed way back in 2018. Hi sir, in your AdMath class, when will equation? Are you talking about AdMath class? So we're doing functions right now in AdMaths, and after functions we'll do modulus graphs and all that. Okay, so I'm going to start now. A-level streams I'm starting inshallah from either this week, as in over the weekend, or coming week. Coming week inshallah there will be a lot of streams for AS Math. Anyway, so let's start. Here's a question. Let's see what it says. In this question, all distances are in meters and all times are in seconds. So we'll start with some easier questions. I'm not going to tell you where I live. I can tell you I live in Karachi, but that's all you're getting. Anyway, so let's solve this question. In this question, all distances are in meters and all times are in seconds. So like I said, we'll start with some easier questions and gradually increase the difficulty level. So easier questions are the ones where there's no calculus involved, in the sense that you don't have to differentiate or integrate anything. It's just pretty straightforward. Difficult questions are the ones where you have to differentiate, integrate, find area and stuff like that. So we are going to start with a fairly easy question. Now this question says, the diagram shows the velocity v to t time graph for a particle traveling in a straight line. The particle travels a distance of 2750 meters in 120 seconds. So that means this is a velocity time graph. What is it of a velocity time graph? But I don't have the time to do concept, okay? So I want to do past paper questions. If you want the concepts, you can watch the conceptual video, which, I've literally done the entire concept from scratch. So aapka cover ho jayega from last year. Last year. Find the velocity v of the particle when t is equals to 70. So we need to find this out. It's a 2-mark question. Let's see what's the piece of information that we can use. The piece of information that we can use is the fact that we're given distance. So I'll write down some concepts along the way. So area under velocity time graph gives distance. Okay, remember, area under the velocity time graph gives distance. So let's find out the area. Now notice that we can divide the area into three parts. Here's one part. Okay. Here is another part. This is a trapezium. Okay, and here's the third part. So we can divide the area under the graph into three parts. One is a rectangle, one is a trapezium, and the other is a triangle. So let's start with a region 1. So region 1 is a rectangle, so we can simply do 10 times 30, which is equal to 300. Pretty simple. Then let's talk about region 2. So region 2 is a trapezium where the parallel lengths are 10 and V and the height is 40. Okay, so parallel lengths are vertical, that means the height will be horizontal. So that means 1 upon 2 into 10 plus V into 40. Let's simplify this. 2 1s are, 2 20s are. So we have 10 plus V into 20. So that's going to be 200 plus 20V. Okay. Next, let's talk about region number 3. So region number 3 is a triangle where the base is the difference between 120 and 70. So that's 50 and the height is V. So that means half into 50 into V. So 50 upon 2, that's 25. So 25V. Now let's add them up. And when we add them up, we will have the distance traveled, which is equal to 2750. So that means 300 plus 200 plus 20V plus 25V is equals to 2750. So 20 plus 25 is equals to 45V. Now 300 plus 200, that's 500. 2750 minus 500, that's 2250. Now we find out the value of V by dividing 2250 by 25. So the answer is V is equals to 50, and that's what we had to find out. 50 meters per second is the answer. Don't worry about the unit. You're not penalized for not writing the unit, but the correct answer is 50. Okay, so I hope it's clear now. No, it's not 32.6. You probably made a calculation error. The correct answer is 50. Now, part 2. Find the acceleration of the particle for 70 to 120. So 70 to 120, that means this is the duration where we have to find out the acceleration. You'll find this worksheet. Check the link in the description. I'm pretty sure I've uploaded this worksheet over there. Okay, please check the link in description. If it's not, you can tell me. I'll upload it right now. So remember, it's the gradient slash the derivative. Okay, it's the gradient slash the derivative of velocity that gives acceleration. For those of you who want the concept or the notes, please check out my detailed video on kinematics. You'll find the concepts as well as the notes in that video. So let's find out the gradient. Remember, now we know V is 50. So what's the change in velocity? That's 50 minus 0. Part B says it's the same question, okay? So notice how so look at how many marks this carries. 2 plus 2, that's 4. 4 plus 4, that's 8. 8 plus 1 is 9. So it's a 9-mark question on kinematics. So just so you guys know how important calculus really is. A different particle moves in a straight line. So we're talking about a different particle. That means it's not connected with the previous question. Such that its velocity v meters per second, t seconds after leaving a fixed point O is given by so and so. Find the exact acceleration. Exact acceleration means that you're not supposed to take the square root, or you're not supposed to, basically you're supposed to leave it in its exact form. So what are we going to do? We're going to differentiate. So when you differentiate velocity, dv upon dt is equals to a. Okay, so let's differentiate velocity. dv upon dt is, and we'll have to use quotient rule, or product rule over here. Okay, so velocity, that's, I guess that's why it's a 4-mark question. T squared plus 5 to the power half. So u is equal to t, that means u prime is equals to 1. U is equals to t squared plus 5 to the power half, which means v prime is going to be equal to 1 upon 2 into t squared plus 5 to the power half minus 1, which is minus half, multiplied by the differential of the bracket, which is equal to 2. So this cancels. Let's write it nicely. So it's going to be equal to t upon t square plus 5 raised to the power half. Okay, so product rule says vu prime plus uv prime. So vu prime means, let's drag this here so we have some room. So vu prime means t multiplied by t over t square plus 5 raised to the power of half. Remember, this is acceleration, okay? Plus vu prime, so that's going to be t square plus 5, the whole thing power half. Now we need to find out the acceleration when t is equals to 2. So all you got to do is plug in 2. So a is equals to t squared, which means 2 squared. 2 squared is 4, 4 plus 5 is 9, so the square root of 9. So that means in the denominator we have the square root of 9. Plus here also we'll have the square root of 9. So let's see what do we get. We get 4 upon 3 plus 3. 4 upon 3 plus 3, which is equal to 4 divided by 3 plus 3, that's equal to 13 upon 3. So the correct answer is 13 upon 3. I hope that's clear. Just a minute. Okay, sorry about that. So, sorry about that. Hope it's clear now. Hope the screen and everything is visible now. Sorry about that glitch. Anyway, so when will you do video? I'll do that very soon. But anyway, here's the answer to this question. We found the exact acceleration when t is equals to 2. Okay, part 2. Explain why the particle does not change direction for t is greater than 0. Now remember, if the particle changes direction, that means v will be less than 0. Okay, if the particle changes direction, that means velocity will be negative. Now, if you look at the velocity equation here, if you look at what velocity is actually equal to, you will notice that if t is greater than 0, then any value of velocity will also be greater than 0. Okay, so if t is greater than 0, that means velocity will also be greater than 0. So therefore, the direction does not change. All right, so that was one question. I hope it's clear. Now let's move on to the next question. No, it's moving in a straight line, but it can still change direction and be moving in the opposite direction. Okay, that's still possible, that it's moving in a straight line and it changes direction and starts moving in the opposite direction. But the reason why it does not change direction is because of the equation. Okay, now let's do another question. Let's see what this question says. Can you make a video on integration? I recently did a vote on my Instagram. I don't think I've done it for AdMaths, but I'll do one for AdMaths also. So please give your input, and whichever topic has the most number of votes, that is the topic that I'm going to stream. Okay, so here's another question. Let's see what it says. A particle P moves in a straight line such, नहीं समझ आया कौन सा वाला part? ये वाला part? देखो, I'll explain this again. So if t is greater than 0, then t squared plus 5 will also always be positive. Notice what the question is saying, that explain why the particle does not change direction for t is greater than 0. So if t is greater than 0, that means this will also be positive, and that means this will also be positive. So that means the overall value of velocity will always be positive. And if velocity is positive, physics students, what does that mean? If velocity is always positive? Hey, you don't have to be a physics student to know that. Just remember that if velocity is always positive, that means the object is moving in just one direction. Okay, how do we know by looking at the velocity that the object has changed direction? That is if the velocity becomes negative. Okay, So I hope it's clear. Now here's another question, and these kind of questions are slightly more difficult, as in slightly, you need to first understand the concept. So here, the acceleration is constantly changing, but you have to keep in mind that for every time, for these two time intervals, there are different values of equations. Okay, so for the first 3 seconds, the acceleration can be calculated by this equation, and for greater than or equal to 3, that means this is the value of this is the equation of acceleration that we're going to use. Okay, so I repeat, for any value of t that's in between 0 and 3 inclusive, we'll use this equation, and for any value of t which is greater than or equal to 3, we'll use this equation. And just so you know, that if let's say you use 3, so because 3 is common, 3 is here as well as here, so it doesn't matter which one you use, you'll get the same value. Okay? Now, as far as acceleration is concerned, a particle P moves in a straight line such that t seconds after passing a fixed point O, its acceleration a meter per second square is given by so and so. When t is equals to 1, the velocity of P is equals to 2 meters per second, and its displacement from O is minus 4 meters. So that means when t is equals to 1, the velocity is equal to 2, and the displacement is minus 4. Okay? Now let's see what the question says. Find the velocity of P when t is equals to 3. Okay, so finding the velocity is fairly simple. All we have to do is differentiate. Now, what should we differentiate? Let's see, what's the equation that we should differentiate? We can actually no, not differentiate, integrate. Sorry. So integrating velocity with respect to time will give us, integrating acceleration with respect to time will give us velocity. So acceleration is equals to 6t. If I integrate it, that means v is equals to 6t square upon 2 plus c. Now notice we want a value of t and we want a value of v, which we can plug into the equation and find out the value of c. So we are going to use t is equals to 1 and v is equals to 2. So that means 2 is equals to 6 into 1 squared divided by 2 plus c. So 2 is equals to 6 into 1 is 6, 6 upon 2 is 3 plus c, c is equals to minus 1. Okay, so now that we have the value of c, we can find out the velocity. The equation for velocity is 3t square minus 1. So simply plug in t is equals to 3. So that means 3 into 3 square minus 1. 3 into 3 square is going to be 27. 27 minus 1 is equals to 26 meters per second. So there you go. That's the answer. So how many marks calculus come in P1, P2? A lot. Calculus makes up most of your paper, so I can't tell you exactly how many marks, but I would say easily around 30 to 40%. Find the displacement of P from O when t is equals to 3. Okay. So what do we have to find out? We have to find out the displacement. Now, notice that we already have the equation for velocity, which is equal to what? Which is equal to 3t square minus 1. Okay. How do we go from velocity to displacement? We integrate velocity and we get displacement. So if I integrate velocity, I get displacement, which is going to be 3t cube upon 3 minus t plus c. Okay. So we need a value of t and s to find out the value of c, but first let's simplify this. So this is going to be t cube minus t plus c. So notice the question earlier gave us that when t is equals to 1, s is equals to minus 4. So let's plug in this, t equals to 1, s is equals to minus 4. So if I plug this in, we get minus 4 is equals to 1 cube minus 1 plus c. So that means c is equal to minus 4. Now that we have the equation for displacement, it's t cube minus t minus 4. All we have to do is plug in t as 3. So let's do that. 3 cube minus 3 minus 4. So 3 cube is 27. 27 minus 3 is 24. 24 minus 4 is 20. So that means the displacement is 20 meters. Let's see if that's the correct answer. Yes, it is. Yes, I think the next stream that I will do will most likely be either on differentiation, integration. So where do I study asymptotes from? Yes, I'll upload a video on asymptotes. Asymptotes and graphs, that's in my list. Inshallah, I'll upload a video. Find an expression in terms of t for the displacement of p from O when t is greater than or equal to 3. Now notice that for t is greater than or equal to 3, the equation for acceleration that we were given was 18e cube upon e power t. 18e cube upon e power t. So that means what we have to do is we have to integrate this once to get velocity, and then we'll have to integrate it again to get displacement. So we have to integrate it, but not once. We actually have to integrate it twice. Now, how will you integrate it? First, let's write it nicely. A is equals to 18e cube e raised to the power minus t. So this is basically a constant. Okay, don't treat this as a variable. So when we integrate it, we get velocity. So 18e cube as it is. So I hope you guys remember how to integrate exponential functions. And then we will divide it by the differential of the power. And don't forget to do a plus c as well. So that means velocity, the equation for velocity is equals to minus 18 e cube e raised to the power minus t plus c. Now if you go back, notice that the question has made us find out the velocity of p when t is equals to 3. Okay, the question has already made us figure that out. And that's the value that we're going to use. Because we can plug in, we can use this equation for time 3 as well. So that's the value that we're going to use, that when t is equals to 3, the velocity is equals to 26. Is integration in the syllabus? Of course integration is in the syllabus. ln integration, no, that's not in the syllabus. Okay, so 26 is equals to minus 18 e cube e raised to the power minus 3 plus c. So 18e cube into e power minus 3, remember the powers will be added. That's going to be e power 0. So that's going to be 26, which is 1. So minus 18 into 1 is simply minus 18. And c is equals to 26 plus 18. What's that equal to? That's equal to 44. So it's a lengthy question. And it's a tricky one as well, so make sure that you guys are paying attention. So we now have, after all this effort, we have found just the equation for velocity. That means we have to integrate it again to find out the equation for displacement. And we have plenty of space. Okay, don't worry about the number of space that we have plenty of space. So let's integrate it again. So when we integrate it again, we get displacement. And this will be minus 18 e cube e raised to the power minus t. Once again, divide by the differential of the power, which is going to be minus 1, plus 44t plus c. Okay, so let's simplify this. So this becomes 18 e cube e raised to the power minus t plus 44t plus c. Now once again, we need a value of t and we need a value of displacement to find out the value of c. And notice that the question again had already made us find out the value of s when t is equals to 3. And because 3 is a common value of time, we can use that as well. So when t is equals to 3, the displacement was equal to 20. So let's plug that in. So 20 is equals to 18 e cube e raised to the power minus 3 plus 44 times 3 plus c. Okay. So e power 3 into e power minus 3 is e power 0, which is equal to 1. So 18 times 1 plus 44 times 3. Let's see what that is equal to. 44 into 3. That's 132 plus c. Okay. So 20 is equals to 150 plus c. That means c is equals to minus 130. And that's it. We now have the correct answer. Plus 44t minus 130. This is the equation for displacement. Okay, so what's the debate? Threshold. I can't say anything about the threshold, but threshold, that's like, what example should I give? I don't know, I can't think of an example, but you're asking me to tell you the threshold without even looking at the difficulty level of the paper. So that's not possible. Threshold is something that's taken into account after difficulty level of the paper. Okay, after you have taken into account the difficulty level of the paper. Yeah, that's what I was trying to say. Anyway, so that was a tricky question. Let's do another question. Actually, this question is a question very similar to the previous question. Let me see. Let me read it. A vehicle travels along a straight horizontal road at time t equals to 0 seconds. The vehicle traveling at a velocity... Okay, no, not very admaths type. Very basic math type. Let's do this. But please note that no study plan will work unless you work. So study plan, don't waste your time trying to look for a study plan. Yes, they're helpful, but a study plan that works for one student is not going to work for the other. So it's best that you start studying and you figure it out along the way. Figure out what your strengths are, your weaknesses are, and then make a study plan for yourself. Okay, so don't waste your time trying to look for the perfect strategy. You won't find it, number one. And number two, you'll end up wasting a lot of time. Okay, so pick up past paper, start solving, that's it. A particle moves in a straight line. The velocity v meters per second of the particle at time t seconds, where t is greater than or equal to 0, is given by so and so. Find the value of t for which the acceleration of the particle is 0 meters per second. So the key word over here is acceleration. And how do we get acceleration? We differentiate velocity with respect to time. Now, it would be stupid to use product rule over here. Let's just expand. So velocity is going to be equal to t squared minus 5t minus 4t plus 20, which means v is equals to t squared minus 9t plus 20. So that's the equation for velocity. Let's differentiate it so we get acceleration. So dv upon dt is 2t minus 9. Let's set this equal to 0. So 2t minus 9 is equals to 0. That means t is equals to 9 upon 2 or 4.5 seconds. That's it. Okay, that's the answer to the first part. Part 2 says, find the set of values of v for which the velocity of the particle is negative. So that means we want the velocity to be less than 0, which means we want t minus 4 into t minus 5 to be less than 0. So this is a quadratic inequality. Okay, so this is a quadratic inequality. Now, quadratic inequality means this is what we're going to do. We're going to make a quadratic curve, and a quadratic curve such that it's cutting the x-axis at 4 and 5, and we want the range of t where the curve is below the x-axis. That means we want the range of t that will give us this part of the curve. Okay, if you don't know quadratic inequalities, you can't solve this. So go back and revise quadratic inequalities if you don't know what I'm doing. So what's the range for this part of the curve? It's from 4 to 5. That's the answer. There you go. Sir, Maths P1 have structured questions. Now, how do we practice them? Should we try and solve those questions from P2 without a calculator? Okay, so if you're talking about IGCSE Math students, here's what you should do. You should practice paper 2 questions without a calculator, and for practice, you can do O-level math paper 1. Okay, so practice O-level math paper 1, practice IGCSE Math paper 2 from previous years for practice. So how did you understand it's a quadratic inequality? Well, this is a quadratic expression. This is an inequality. So combined, this makes a quadratic inequality. Okay. Find the distance traveled by the particle in the first 5 seconds of its motion. Okay. So distance traveled. What is it that gives you the distance traveled? The distance traveled is basically calculated by taking area under the velocity time graph. Now, if you recall the equation for velocity time, it's t squared minus 9t plus 20. That means this graph looks like this. Okay, and you want the distance traveled in the first 5 seconds of its motion. So this is 4, this is 5. Now, here's what we're going to do. We want this area and we want this area. So we cannot just integrate velocity within the limit 0 and 5 because in between the object is turning. So this is wrong. Instead, what you're going to do is you will first integrate velocity within the limits 0 and 4. And then you're going to again integrate velocity, but this time within the limits 4 and 5. And because you want distance, you will take the modulus of it, meaning that you will take the absolute value of it. All right. Why the absolute value? Because this will give you negative. Negative sign is trying to tell us that it's below the x-axis, but we will take it as positive because we want the distance only. Now, so t square minus 90 plus 20 is what we are integrating within the limits 0 and 4. So let's do this first. So this is going to be t cube upon 3 minus 90 square upon 2 plus 20t within the limits 4 and 0. Okay, so first let's find this out. Do we have to draw the graphs for this type of question to understand? Yes, because, and it's not like drawing a graph is something that you would know how to do this anyway, because it's part of your syllabus. So it's always a good idea to draw the graph. Now, let's work this out. T cube, that means 4 cube upon 3 minus 9 into 4 squared upon 2 plus 20 into 4. So this gives you, all right, you're welcome, 88 upon 3. Okay, this gives you 88 upon 3. Now, why do we need to take the absolute value? Because we will get a negative answer, which means that the question is trying to tell us that it's below the x-axis. Okay, and because it's below the x-axis, we have to, and since we're finding out distance, we are going to take the positive value. Yes, you can do it directly in your calculator also. In fact, I'm going to do that just to check my answer, because I think there's something wrong with my answer, just to be on the safe side. No, there's nothing wrong. So it's 88 upon 3. Then we are going to integrate the same equation within the limits 4 and 5. And this time, like I said, we'll get a negative answer, but we will take the modulus of it with respect to time, You don't have to buy my notes. My notes are available for free. My notes are actually will be available on the website very soon. You don't have to buy them. Okay, so don't waste your money. Now let's find this. And here also, we're going to use the same equation, except this time we're going to plug in the limits 5 and 4. Okay, so beta, please do not spam. I'm afraid I'll have to take action. Now, here also I'll just write down the final answer to save some time. So let's integrate this. I hope you guys know how to do this directly in your calculator. X squared minus 9x plus 20 within the limits 4 and 5. So this gives us minus 1 upon 6. Okay, but remember what I said? I said that we're going to take the positive value, which is equal to 1 upon 6. Now, 88 upon 3 plus 1 upon 6. Let's see what that gives us. 88 upon 3 plus 1 upon 6. That gives us 59 upon 2, which is the correct answer. There you go. Okay, so I hope it's clear. I'll give you guys a quick summary. So we need to find out the distance traveled. Remember, as whenever the particle turns, how do we know that it turns? Because the velocity is equal to 0 at 4 and 5. Okay, you can find out earlier that if velocity was equal to 0, we would get two different values of t. One would be 4, the other would be 5. So that means the object is turning. And whenever the object is turning, distance and displacement are two separate values. They're not equal. So a good idea is always to make a graph. So this is what the graph would look like. And why are we making the graph? Because we know area under the graph is equal to distance traveled. So we first find out this area under the graph, which is in between 0 and 4. Then we find out this area under the graph, which is in between 4 and 5. How do I know this? I know this because this is a quadratic curve with x-intercepts 4 and 5. No, you don't need to take modulus on your calculator. Your calculator will give you a negative value. Just turn it into positive. Simple as that. Anyway, let's do another question. Let's try and solve at least 7-8 questions in today's class. And I would like to do one of those questions where we have to make a graph. Yeah, in fact, let's do this question. This question came in recent years. Yeah, it came in May, June 2022. And it became a very discussed question. A lot of people struggled with this question. Let's see. सर वो डी वाला करवाएं जिसमें टर्न होता है. Achha, you're talking about that? We could do that, but do it this way, because like I said, I didn't say it yet, but I'm going to say it now, that majority of the questions will be structured in a way that they will encourage you to use area under the graph by integration. Find out the area under the graph by integration. Really, website says server not found? Maybe it's down for some maintenance, so I can open it. It's working fine. So there's probably some error at your end. But anyway, so as I was saying, to find out distance traveled, it's best that you use area under the graph. Okay, you can use that, but like I said, most of the questions are structured in a way that they naturally nudge you in the direction where you use area under the graph. बेटा ज़रा instructions और title पढ़ लें, ठीक है? आप वही लोग हैं जो पेपर में instructions नहीं पढ़ते. So read the title, you'll find the answer to your question. In this question, all lengths are in kilometers and time is in hours. A particle P moves in a straight line such that its displacement from a fixed point T is given by S is equals to T plus 2, T minus 5, the whole thing square for T is greater than or equal to 0. Find the values of T for which the velocity of P is 0. Okay, so we have the displacement. How do we turn the displacement into velocity? We differentiate it. So ds upon dt is equals to v. Now let's differentiate it. We'll have to use quotient rule. So u is equals to t plus 2, which means u prime is equals to 1. V is equals to t minus 5, the whole thing square, which means expand. We could expand, but let's do it without expansion. So v prime is equals to 2 into t minus 5, which can be written as 2t minus 10. Okay, so vu prime plus uv prime. Vu prime plus uv prime. So vu prime means t minus 5, the whole thing square, plus uv prime means t plus 2 into 2t minus 10 is equal to what? Is equal to 0. So I guess I'll have to expand it. Yeah, I'll have to expand it. I think I should have expanded it earlier only. So t square minus 10t plus 25 plus 2t square minus 10t plus 4t minus 20 equals to 0. But I think this is that very question only. Okay, this is the exact same question that you've asked, coincidentally. So t square plus 2t square is equals to 3t square minus 10t, that's minus 20t, minus 20t plus 4t, that's minus 16t. 25 minus 20 is equal to 25 minus 20 is equals to 5. That's equal to 0. Okay, I remember you're supposed to enter the equation without integrating it. Maybe you entered the equation after integrating it. No, your calculator will integrate it itself. Just write down the equation for velocity, and maybe you're not using the correct feature. Anyway, so this is the equation for velocity. Let's see if it's correct. Yeah, looks good so far. Now, when we set it equal to 0 and we solve, so I'm going to skip the solve part where you solve a quadratic equation and just write down the answer directly. So we have t is equals to 1 upon 3 and t is equals to 5. Okay. Now, on the axes, draw the displacement time graph for p for 0 to 6, stating the coordinates of the point where the graph meets the coordinate axes. Now, s is equals to t plus 2 into t minus 5, the whole thing square. YouTube पे देख लो, कोई ना कोई वीडियो मिल जाएगी how to do integration in your calculator directly. Okay, थोड़ा खुद भी effort कर लो, you'll figure it out. Now, notice that this is a cubic graph, and cubic graphs are part of your syllabus. Okay, so cubic graphs are part of your syllabus, and here the coefficient of t cube is greater than 0, which means it's going to be a minimum maximum curve. Okay, it's going to be a minimum. Actually, no, it's going to be a maximum minimum curve. Okay, and what about the x-intercepts? The x-intercept will be t is equals to 5 and t is equals to minus 2. Now, obviously, we can't show t equals to minus 2, but we can show t is equals to 5. So here it is. Okay, another important thing to learn is that the question has already made us find out the turning points. Okay, why do I say that? Why do I say that the question has already made us find out the turning points? Because we found out when is the velocity equals to 0. So that means we differentiated it and we found when it's equal to 0. So these are the values of t. So that means these are the points where the graph will turn. Now what about the y-intercept? So if you plug in t equals to 0, you get s equals to 0 as well. Okay. So here's one point. And as far as the x-intercepts are concerned, here it is. And remember, we just have to make sure that we show the correct. Actually, no. Wait a minute. When t is equals to 0, s is not equal to 0. Sorry, my bad. When t equals to 0, s is equals to 0 plus 2 is 2. 2 into minus 5 squared. So minus 5 squared is 20. 20 times 2 is 50. So that means when s is equals to 0, we get 50. So we're going to have a curve that looks like this. And then it turns at 5. And there you go. Okay, this is what we get. Now s is not 100, is it? Is it 100 or is it 50? Let me check. Let's just use a calculator. So 2 into 5 squared, it's 50. S is 50. Okay, so I'll repeat. We are making a cubic curve. Okay, a cubic curve which is a maximum minimum curve. And we have already found out the x coordinate of the turning point here by equating velocity to 0. So 1 is 1 upon 3. Although you're not supposed to show that, you're only supposed to show the points where the graph meets the coordinate axes. That means you're supposed to show the y-intercept and the x-intercept. But do keep in mind that this is the point where the curve will not only touch the x-axis, but it will also turn. Okay, so I'll write down over here that these are the turning points of displacement time graph. Okay, so that's the displacement time graph. Now, this very question is now asking us to draw a velocity time graph for 0 to 6, stating the coordinates of the points where the graph meets the coordinate axes. Now, for this, we need the equation for velocity. Here it is. This is the equation for velocity. Let's copy this and paste it here. And notice that we have already found the x-intercepts for this equation. Why? Because when we equated this equation to 0, we found out two different values of t. These values represent what? These values represent the x-intercept. So one x-intercept was 1 upon 3. So 1 upon 3 means that it's going to be somewhere over here. And the other x-intercept that we got is 5, which means it's going to be somewhere over here. And what about the y-intercept? The y-intercept is going to be 5. So this is what the curve will look like. There you go. That's it. Okay, now we have the velocity time graph. Let's see what the next part is. Write down an expression for the acceleration. So how do we find out acceleration? We differentiate velocity with respect to time. That's going to give us 6t minus 16. So that is acceleration. 6t minus 16. There you go. Now this is going to be a straight line. And the y-intercept is minus 16. To find out the x-intercept, plug in a as 0. So a equals to 0. That means 6t minus 16 is equals to 0, which means 6t equals to 16, which means t is equals to 16 divided by 6, which is equal to 8 upon 3 or 2 whole 2 upon 3. Okay, so that means 2 whole 2/3. That's going to be somewhere over here. And that's it. You join these two together. Now you have the acceleration time graph as well. Okay. So there you go. Our difficult question. And how many marks? 2 plus 1 is 3. 3 plus 2 is 5. 5 plus 2 is 7. 7 plus 4, 11. 11 marks for this question. Okay, let's do another question. So now let me see what questions you guys have asked so far. I don't teach A-level math. I'm sorry, I don't. So after this exercise, can you Kinematics math from... I don't know if I already have that question. If I do, I'll probably take it. February, no, May, June 2023. Okay, let's see if that question comes. Okay. Now, sir can take another value than 0 ek pura calculus ki stream. Now, why can we take another value than 0? We want the x and y intercept, so we'll have to take time as 0 and then acceleration as 0. Okay. Now, let's do another question. This is a question where we have trigonometric function. Okay. Let's see how we can do this. The velocity v meters per second of a particle moving in a straight line t seconds after passing through a fixed point O is given by v is equals to so and so. Find the time at which the acceleration of the particle is first equal to minus 9 meter per second square. So once again, we have acceleration. Now this is be careful, this is a trigonometric equation. So we will differentiate velocity with respect to time to get acceleration. So let's see what's that equal to. So dv upon dt will be equal to 6 differential of sine is cos multiplied by the differential of the angle, which is 3. So that's 18 cos 3t, which is equal to acceleration. Now we want to find out the value of t when acceleration is equals to minus 9. So minus 9 is equals to 18 cos 3t. Now we have a trigonometric equation to solve. That means cos 3t is equals to minus 1 upon 2. So solve this like you would solve a normal quadratic equation. Cos is negative. And remember, any trigonometric equation of kinematics is to be done in radian mode only. So A, S, T, C. Cos is negative, that means could be in the second quadrant, could be in the third quadrant. So we find alpha by taking cos inverse of 1 upon 2, which is equal to pi upon 3. So that means one possible value, since we only want the first value, okay, so we're not going to take this angle. So 3t is equal to pi minus pi upon 3, which means 3t is equals to 2 upon 3 pi. And now we can solve for the value of t, which is equal to 2 upon 9 pi. There you go. So I hope it's clear now. Now when will you do 4024? I'm most likely going to do mensuration this weekend. So I announce all the streams on my Instagram. So you can find out if you're following. Why first? Because the question says so. And as far as what topic I should stream, well, I always do a vote. Actually, no, I started doing a vote recently. So you guys can give your input and I'll stream whatever topic has the most number of votes. Now, I'll be doing past paper questions. This weekend, most likely, I'll be doing past paper questions. Find the displacement of... Congrats. Yeah, thank you. I realized that my channel has hit 80,000 subscribers. Those of you who are watching, if you haven't liked the stream yet, please do so. And if you're watching and you haven't subscribed, please do that as well. 3D. I'll be doing 3D. 2D is easy. 3D karenge kal, inshallah. Anyway, part B. Find the displacement of the particle from O when t is equals to 5.6. So notice we're given the velocity, which is equal to 6 sine 3t, 6 sine 3t. So we'll integrate both sides to get displacement. So integral of sine is minus cos. So 6 into minus cos 3t, and we divided by the differential of the angle, so that's minus 3. And don't forget, every time you integrate, there's going to be a plus c. So it's going to be, sorry, not divided by minus 3, divide by 3. Minus 2 cos 3t plus c. Now notice that this question said that the particle started from O. Every time a particle starts from O, that means when t is equals to 0, s is equals to 0. So we're going to plug that in to the equation. 0 is equals to minus 2 cos 0 plus c. Cos 0, remember, is 1. So minus 2 plus c. c is equals to 2. Okay? Now, let's put this together. So we have minus 2 cos 3t plus 2 as the equation. And this is what we were supposed to find. No, actually, we are supposed to find out the displacement when time is equal to 5.6. Make sure your calculator is in radian mode. So minus 2 cos 3 into 5.6 plus 2. So displacement is equals to 2.92 meters. And that's it. That's the answer. Sadly, I'm in AS level now and there are barely any AS. Okay, I haven't done a lot of streams, yes, but I have a lot of topics covered of AS. You'll find a lot of videos. I've covered trigonometry, I've covered functions, I've covered transformations of functions, binomial, APGP, circular measure, pretty much the entire AS syllabus. Yes, I haven't done any streams lately, I agree, but I'll start soon, inshallah. Anyway, let's do one or two more questions. Let me pick a difficult one. Yeah, let's do this. Or, yeah, let's do this. This is a nice question. Let's see what it says. It says a particle P travels in a straight line so that, yeah, no videos on normal distribution, I know. Inshallah, before the CIE exam, I'll have normal distribution covered as well, inshallah. A particle P travels in a straight line so that t seconds after passing through a fixed point O, its displacement s meters from O is given by so and so. Find the value of t when P is at instantaneous rest. Now remember, whenever the object is at instantaneous rest, velocity is equal to 0. Whenever it's at rest, velocity is equal to 0. So we'll differentiate this, ds upon dt. So that's going to be 0 minus e to the power t upon 3 as is, because when we multiply it by the differential of the power makes no difference, minus 10 e raised to the power minus t multiplied by minus 1. Okay? Answer your question. Sir, is differentiation of implicit functions included in IGCSE further pure maths? I wouldn't know about further pure maths. I guess that is edXL. I don't know. I haven't taught edXL in a very long time. So I can't, it's best that you ask someone who teaches edXL on a regular basis. So plus 10 e raised to the power minus t. And what's this? This is the equation for velocity. Okay? Let's just get rid of the 0 minus. So that's good enough. Now, the question is asking us to find out the value of t when p is instantaneously at rest. So that means we're going to set this equal to 0. So e power t upon 3 plus 10 upon e power t equals to 0. Okay? Now we take the LCM, which is going to be 3 e power t. So we multiply this by e power t and we multiply this also by e power t. So e power t multiplied by e power t becomes e power 2t. We multiply this by 3, we multiply this by 3 as well. So plus 30 equals to 0. Now if you cross multiply, so that's e power 2t plus 30, which is equal to 0. Okay? So what do we have to do now? We now have to solve this. Let's see how we can solve this. So let's first, in order to solve this, we'll have to use ln. Okay, we'll have to use ln. So e power 2t is equals to minus 30. But wait a minute. All right, I just realized this is supposed to be minus. Yeah, so minus minus cancel. And now ln e power 2t is equals to ln 30. So 2t is equals to ln 30. Let's work out the value of t. So ln 30 divided by 2, and that's equal to 1.7. Let's see what the question said. Correct to two significant figures. So 1.7 is the correct answer. Now, that is the answer to the first part. Now let's do part 2. Find the distance traveled in the first 2 seconds. Okay, be careful over here because the particle comes to rest at t equals to 1.7. So that means at t equals to 1.7, the object turns. The object turns. So you will find the distance traveled by integrating velocity, but you will have to do it in parts. Okay, you can't do it directly, you'll have to do it in parts. How? Here's how. So you will have to first integrate within the limits. Iski baat kar rahe the aap? Okay, I don't know what you're saying, but khair. You will have to first integrate velocity within the limit 0 and 1.7, then you will have to integrate velocity within the limits 1.7 and 2. Now 1.7 and 2 is integrating velocity is not something that you'll have to do from scratch. You already know what the displacement is. Okay, you already know what the displacement is, so we're just going to use that. So 31 upon 3 minus e raised to the power t minus e raised to the power t upon 3 minus 10 e raised to the power minus t. So in this, we're going to plug in the limits 1.7 and 0. Okay, so we're going to plug in the limits 1.7 and 0. So let's do that. I'll show you guys actually how to do it using your calculator. So make a fraction, 31 upon 3 minus, make another fraction, e raised to the power 1.7 upon 3 minus, make another fraction. Actually, no need to make another fraction. Minus 10, shift e raised to the power minus 1.7. Yes, there we go. So let's see what we get. We get 6.6818. Don't round this off. Let's take it exact. Let's take as many decimal places as possible. Now we're going to integrate this once again, but this time the limits that we're going to use are going to be 1.7 and 2. 1.7 and 2. Okay. So actually, no, wait a minute. Now let's plug in 0. I just realized that I didn't plug in 0. So let's plug in 0. And here also, let's plug in 0. So we get 0. Okay, thank God. We get away with it. 6.68. Okay, you're right, 6.68. Thank you. Does anyone remember exactly what it was? 6.68. 68 के आगे क्या था? याद है किसी को? खैर नहीं भी याद तो कोई बात नहीं. Let's plug in the upper limit. So when we plug in the upper limit, here's what we get. We get 6.5169. Okay. Then if I plug in the lower limit, 6.68148. So that's going to be 6.68148. Okay, thank you so much. I appreciate it. 6.68148. Okay, now let's work this out. 6.5169 minus 6.6814. 184. Okay, sorry. 184. 6.68184. Okay, so here's what we get. We get minus 0.16494. Okay. Now when we take the modulus of it, so obviously we'll have to add this. So isko hum abhi into minus 1 kar lete hain taaki ye plus ho jaye. Plus 6.68184. 184. Sorry, 184. 6.68 184. अच्छा मैं यहाँ पे भी ठीक कर लूँ. 6.68 184. So finally we get the correct answer, which is 6.84678, which correct to 3 significant figures is going to be 6.84. Yeah. Thank God. Okay. So I hope that's clear. Now this question has more parts. We've done the difficult part. Now it's all downhill. Let's see what this says. A particle Q travels in a straight line so that t seconds after passing a fixed point O, its velocity. So once again, you can see, we call this basically piecewise. Okay, so for different ranges of t, you have different graphs. Okay, so V is equals to 2t for 0 and 5, so that means it's going to be a straight line. So plug in 0 into the equation, you will get 0. Plug in 5 into the equation, you will get 10. So that means for 0 to 5, this is what the graph looks like. Then after that, it's this is what the final answer is, 6.84, correct to 3 significant figures. Okay, and it's acceptable. It's inside the acceptable range. I have the answer in front of me, so it's acceptable. Okay, I'll tell you what the acceptable range is. 6 point. Okay, I get what you're saying. Correct to 3 significant figures, it's going to be 6.85. Sorry, too many decimal places. My bad. What does that mean? Anyway, I don't know what you mean by that, but khair. Then after that, from 5 and onwards, we have a different graph. Okay, from 5 and onwards, we have a different graph. Okay, I don't know what you mean by that. Anyway, so how do we find out the shape of the graph? What we'll have to do is, notice that it's a quadratic graph, number 1. Okay, and number 2, we need to find out the shape of the graph. Okay, so we need to find out what the graph looks like. We can draw a table. Okay, we can draw a table. Like for example, we can plug in 5, 6, 7, 8. In fact, let's do that using a calculator. ठीक है, अभी सामने ही कर लेते हैं. So let's plug in 5. So that's going to be 5 squared minus 8 times 5 plus 25. So at 5, it's equal to 10. Now let's plug in 6. Let's see what do we get at 6. At 6, we get 13. So that's approximately going to be somewhere over here. And then let's plug in 7. Then let's plug in 8. So 7 pe hamare paas aa raha hai 18, which is going to be somewhere over here. Then finally, when we plug in 8, here's what we get. We'll get 25. Okay, so that means it should look like a curve. It's going to look something like this. There you go. Not drawn to scale, it's a sketch. And there you go. We take 5. 5 is a common point. Okay, 5 is a common point. Now, showing all your working, find the distance traveled by Q in the first 8 seconds of its motion. So first 8 seconds means that we'll have to find out area under the graph. So notice that from 0 to 5, it's a triangle. So from 0 to 5, it's a triangle. We can find out the area of triangle by doing half into 5 into 10. So that's 50 divided by 2. That's 25. Then the reason why it's a 5-mark question, because from 5 to 8, we will have to integrate velocity within the limits 5 and 8. Okay, so that's why the question has given you the equation for velocity as well. So we'll have to integrate it. So that means we'll have to integrate t square minus 8t plus 25 within the limits 5 and 8. So let's do that. That's going to be t cube upon 3 minus 8t square upon 2 plus 25t within the limits 8 and 5. Okay? So let's do that. Let's plug in the values. And I'm just going to save some time and find out the direct answer. For those of you who don't know how to integrate directly using your calculator, here's how you do it. So the key that you're looking for is this key right here. By the way, I have a whole video in which I have explained all the important things that you can do using your calculator in advance. Yeah, it's an old video. I guess it's 2 years old, but it'll do the job. So integrate x square. Okay, we can't write t, so we're going to write x minus 8t. So once again, we're going to write x because we can't write t, plus 25 within the limits 5 and 8. Okay, make sure that you write the integration before, the equation before you integrate it. Your calculator will do the integration for you as well. So this is 48 and here's 25. Let's add them up, see what do we get. 25 plus 48, which is equal to 25 plus 48, that's equal to 73 meters. There you go. Let's see if that's the correct answer. This is question number 9 of the worksheet. Make sure that you guys download the worksheet. You'll find a link to it in the description. Yeah, that's the correct answer. Okay, so let me pick one last question, and that's it. 73, okay, great. काफ़ी है आज के लिए? Yeah, we have covered pretty much all. Okay, let's do this one last question. Because here we have ln. We haven't done a question with ln. We've done a question with exponential, with trigonometry. We haven't done a question with ln. Let's do this last question. A particle P moves so that its displacement from a fixed point O at time t seconds is given by so and so. X is equals to ln 5t plus 3. Find the value of t when the displacement of P is 3 meters. So we're given the displacement, and all we have to do is solve the equation. So remember, the base of ln is e, so that means 5t plus 3 is equals to e cube. 5t is equals to e cube minus 3. That means t is equals to e cube minus 3 divided by 5. Beta, relative velocity? आप ठीक तो हैं? Relative velocity is no more part of the syllabus. बेटा किस दुनिया में रह रहे हैं आप? I think what you mean to say is velocity vectors. I think that's what you mean to say. Now, so e cube minus 3 upon 5. So t is equals to 3.417. So correct to 3 significant figures, it's 3.42. Now, find the velocity of P when t is equals to 0. So how do we find out velocity when we're given displacement? We will differentiate it. So dx upon dt, I hope you guys know how to differentiate ln. It's 1 upon the argument multiplied by differential of the argument, which is 5. And we're going to plug in 0 in place of t. So v is equals to 5 upon 5 into 0, which is 0. 0 plus 3 is 3. So 5 upon 3 meters per second. Velocity vectors, yes, velocity vectors hum kar sakte hain. But I'll do that close to exams, inshallah. Explain why after passing through O, velocity of P is never negative. So notice that the equation for velocity is 5 over 5t plus 3. So the numerator is always greater than 0. The denominator is always greater than 0 for t greater than 0. Therefore, velocity is always greater than 0. Simple. Keep it simple. No need to make it complicated. And that's the answer. Find the acceleration of P when t is equals to 0. So how do we find out acceleration? We need to differentiate velocity. First, let's write it nicely. Let's write it in a way so we can use composite function rule. So dv upon dt will be equal to minus 5 into 5t plus 3. Let's take 1 away from the power. So minus 1 minus 2 into the differential of the bracket, which is 5. So here's what we get. Acceleration is equals to minus 25 upon 5t plus 3, the whole thing square. And the value of t that we're given is equal to 0. So a is equals to minus 25. 5 into 0 is 0. 0 plus 3 is 3. 3 squared. So a is equals to minus 25 upon 9, which I believe, okay, we can leave it as it is. We're not supposed to give it in decimal. We don't have to unless the question says so. But yeah, that's the answer. Okay, so we're going to keep it till here only. Can you explain the v greater than 0 part? So dekho, whenever velocity, time will always be positive, okay? Any value of t that you're going to take will be positive. So for any positive value of t, 5t plus 3 will always be greater than 0. 5 is already greater than 0. So because the numerator denominator are both positive, that means the overall value of velocity will always be 0. Part 2, if all types of done, I don't know what you mean by that. Yeah, we're done with kinematics. We're done with, as in we're done with today's class. And we'll do another part of it if necessary, close to exams. So yeah, I will stop here. Like I said, I will put a vote on my Instagram so you guys can give your input, what topics you want me to stream next. And whichever topic has the most votes, that's the topic that I'll be streaming. Okay, so I'll stop here. See you guys inshallah in the next stream. So take care everyone. Allah Hafiz.